This is the electron transport chain, third step of the cellular respiration cycle. It's located in the mitochondria.
This is NADH. It's an electron carrier and it was created in Krebs cycle. It's going to come from the matrix into protein 1 where it will drop off its hydrogen.
At protein 1, the hydrogen will break into a proton and electron. And also at protein 1, it will pump the proton and pass the electron to protein
In
2.
protein 2, it just passes an electron.
At protein 3, it will take one of the protons in the matrix of the mitochondria and pass it into the intermediate space and then pass the electron.
Protein 4 is just like protein 2, passes an electron. Then protein 5 pumps a proton and the electron attaches itself to an oxygen, which attaches another proton, making half a water.
Then there's diffusion. It goes through. Once that happens, then it gets energy, causing phosphorylation to an ADP to create ATP. Then there's diffusion again. This happens 2 more times, creating 3 for the cycle. And then there's diffusion again.
This is an FADH2. The FADH2 does not fit with the protein number 1, so it moves on to protein number 2. Where it then dumps off its hydrogens.
At protein 2, it breaks into a proton and electron. The protons stay and the electrons pass.
And at protein 3, it passes one of the protons and then passes the electrons down to protein 4.
Protein 4, just like protein 2, passes electrons. Proton is pumped through and the 2 electrons attach themselves to the oxygens, which attack 2 more protons, which attach themselves, making a water and a half.
Then there's diffusion again. This creates another ATP,
And then it happens one more time.
creating 5 ATP total.
This is the electric transport chain. This is the third step of the cellular respiration. This occurs in the inner space of the mitochondria.
So this is NADH, an electron carrier made in glycosis and in the Krebs cycle, steps 1 and 2 of the cellular respiration. And so what this does is it goes to protein 1, and since it fits, this gets placed to protein 1.
It then breaks apart, the protein stays, and the electron passes on.
The electron gets passed on.
Then at protein 3, we use some of the electron's energy to pump through a proton and pass on the electron.
Then you pass on the electron.
Pump a proton and pass the electron, and then oxygen then picks it up. And then proton is attracted to the negative charge and attaches to the oxygen.
Which gives you a concentration gradient, which means you have to diffuse.
Allowing ADP to phosphorylate.
This happens 3 times.
Diffusion.
Next, FADH2 is passed on, and we can't fit protein 1, so we move on to protein 2. And the 2 hydrogen are broke off of it, and the protons stay, and the electrons get passed.
Then we use some of the electron's energy again to pump through a proton and pass on the electrons.
And we pass them again.
We then pump a proton, and then take the 2 electrons and butt them onto the oxygens, and then take 2 more protons and then attach them to the oxygens, making a water and a half of the water.
Which leaves us another concentration gradient, which means you have to diffuse.
Adding phosphate, phosphorylation.
Which gives us equilibrium.